Okay, folks, so we're going to start this quick lesson off with just a review of what the circumference of a circle is, pi d, or 2 pi r. And let's remember that this is a linear measurement, which means that it is the perimeter of the circle. Okay, that means I can walk around it. That's the circumference. We also know that the area of a circle is pi r squared, okay? And that's a square unit measurement, which means that I can paint the inside of the circle. Okay, so what we did in class was we looked at this circle. Okay, remember we named it Lily, L for Lily. And we were trying to find the measure and the length of arc AB. Now we know that arc AB is a part of the circumference because it's this measurement right here. So arc AB, remember, has a measurement, which means it's a degree, 40 degrees because it's the central angle, but it also has a length. And when we did this in class, we had to say, well, if it has a length, that means we have to connect it to what does 40 degrees mean? Well, 40 degrees is 1/9 of 360. Now this is all a review. So remember, when we see this 40 degrees, we want to make it into a fraction, and if I can reduce that fraction, I'm going to reduce it. So if I can find the circumference of this circle with my 8 centimeters, I can find the length of this arc by taking 1/9 of the entire circumference. So again, that's what we did in class. So the circumference of this circle is 16 pi. Okay, that's the whole circle. And if we're going to take 1/9 of that to find the arc measure, the arc length, excuse me, we're just going to say the arc length is going to be 1/9 of that. So I just divide that by 9. Okay? And let's remember, if we have centimeters, this is a linear measurement, so centimeters is our final answer. And of course, I can put this into decimal form if I want. So that's just a quick review. So why do we need to know area? Well, we're going to look at this as an area. And we're going to talk about something called a sector. And a sector, like an arc being part of the circumference, a sector is a part of the area. So it's like a piece of a pie, a piece of a pizza pie. So if I was to take this guy and color it in, and I want to find the area of this sector. Again, that's new language. Okay? The word sector means it's a piece of the entire area of the circle. So it's like a chunk, okay? And we note that a sector comes from the center. So it's still made by 2 radii. And we still have to pay attention to the central angle. So we know, again, well, 120 is 1/3 of 360. Because 120 degrees over 360 degrees, that gives us 1/3. And again, 120 over 360 is the fraction, and we're just going to reduce it to 1/3. So the question is how can I find the area of this sector? I want you to pause the video and see if you can do it without me. So the first thing I have to do is I have to find the area of the whole circle. And again, area equals pi r squared. Okay? So if area equals pi r squared, my radius is 12.75. So I square that in my calculator. Y'all see my calculator? Yep. Square that in my calculator. And then I multiply it by pi. So the area is approximately 510.70, and I'm going to write all of my digits in here because remember, we're going to practice using all of the digits in the calculator. And don't forget our units. Remember, area is always in square units. So our area is this number here. If this is the entire area, what am I going to do to get just the sector? Well, I simply take that number and I divide it by 3. So the area of this sector is 12.75 squared pi divided by 3. And if I do that in my calculator, I get something that's approximately 170, and let's round to the nearest hundredth, 24 square feet. And that would be my final answer. That's how we find the area of a sector. Let's do another one of these. Okay, so I'm going to do one of these. I'm going to pick any of them, and then I want you to try the other ones on your own. Okay? And we'll go over those in class. So, let's pick this one. This one I'm not going to pick because this one is obviously 90 degrees. So I'm going to give you a hint on number 9 that the sector is going to be a quarter of the whole circle. So you probably can see that already. So I'm going to pick something that's a little harder. Let's see. This guy is 36 degrees. Now this 36 degrees is the central angle. So I have to say to myself, let me get a little closer so you can see this a little bit better. Okay. So I have to say to myself, well, what fraction of this whole circle is this piece of the pie or this sector? So I'm going to write 36 degrees out of 360, and we know that that's 1/10 because I can reduce that fraction. So again, what I'm going to do is I'm going to find 1/10 of the entire area of the circle. So if I have that, I have to find the area of the entire circle. The area of the entire circle, again, I'm just going to rewrite it, is pi r squared. We have to remember that. So the area of this whole circle is going to be 36 pi. Why? Because if the radius is 6, it's 6 squared pi. So the area of this entire thing is 36 pi. And if I want to leave this in terms of pi, I can. So the sector is going to be 36 pi divided by 10. And I can reduce this fraction. So this is a couple of ways that I can write the area of the sector. And I want you to try to really understand how I can write this a bunch of different ways. One way I can write this is in terms of pi with the reduced fraction. So 18 over 5 pi. Do you see how I did that? And let's not forget, there's no units. So I can write square units as my answer. So that's one way I can write this. Another way I can write this, still in terms of pi, is 3.6 pi. Square units. So that's another way I can write that because 36 divided by 10 is 3.6. And a final way I can write this is not in terms of pi at all. I'm going to take this information, 3.6, put pi into my calculator. And so another way I can write this is to the nearest tenth or hundredth, let's say hundredth. So the nearest hundredth is 11.31 square units. So there are 3 different ways that I can write this, but it still means the exact same thing. And that is a sector. So pause and see if you can try these 3. And when you're done with those, come back and we're going to talk about something else. The next thing is called a segment. Whoops, it's this one. Okay? So again, I'm going to bring this up a little bit. And I'm going to show you what we just did. So let's look at what we just did. Here is the sector. And if I take something called a chord, you might be able to see it underneath. Can you see that underneath? Okay. If I take a chord and I attach it to the endpoints of the radii, which are on the circle, this line here is called a chord. And we'll go over that more, like pieces of the circle, when we're in school together, okay? But this is called a chord. Now, this section here is a part of the sector. Would you agree? So what I'm going to do is I'm going to take my straight edge, and I'm going to draw this chord here. It's the same exact thing as what we just saw. And I'll use a black pen. So what's left here is called a segment. That's another piece of language that we're going to learn today. So the cool thing is we already know what the area of the sector is. The area of the sector is 170.24 square feet. So I'm going to bring that up here, and I'm going to write that if this whole thing was filled up, this entire sector was filled up, I know again that my area is 170.24 square feet. That's if I colored this whole thing in. But now I want to find the segment. And that's what this piece of the circle is called. It's called a segment. So a segment is a part of a sector. How do you think we're going to find the area of this segment? So again, I want you to press pause, and I want you to see if you can figure it out before I do it for you. Okay. So it's kind of obvious that here's a triangle. Would you agree? So if I can find the area of this triangle and subtract it from the area of the whole sector, I can find the area of the segment. But the tricky part is, how am I going to find the area of this triangle? That's the tricky part. We're going to have to use a little bit of trig. Maybe not, because maybe we'll even be able to use our special triangles, but let's just practice using trig. So let's remember that in order to find the area of a triangle, you have to have the base and the height. Do you agree with that? You have to have the base and the height. So how are we going to find the base and the height? Well, that's a little tricky. So I first have to draw. I'm going to redraw this triangle for you so you can see it as just a triangle. Okay? So imagine I'm going to redraw this triangle. There's a lot of information you already know here. I know that this is 120 degrees, and I know that I need a base and a height. So that means I'm going to take my green marker, my green pen, and I'm going to draw my altitude. Let's not forget that an altitude is a line that's drawn, whoops, it's a little fuzzy. Okay, a line that's drawn perpendicular to the base. All right, well, I don't know what my base is here, but I do know that this hypotenuse, ooh, now it's a hypotenuse, is 12.75. And I do know that this is 120 degrees. So if this is 120 degrees, half of it is going to be 60 degrees, and the other half is going to be 30 degrees. So I can use trigonometry to find the missing pieces of the triangle. How do I use trigonometry to find the missing pieces? Well, I can find this by using the sine ratio, opposite over hypotenuse. So sine, oops, let's do that again. Sine 30 degrees equals opposite, unknown, I'll call that a height, over hypotenuse. So the height is going to equal 12.75 times sine 30, and I put that into my calculator. 12.75 times sine 30, and that gives me, ooh, a perfect number that I can use, and I don't even have to round. Okay, so that's this guy, 6.375. Now, how do I find the base? Right? Well, the base, I can use sine of 60 degrees, or I could use cosine of 30 degrees. It's entirely up to you how you want to do that. Let's just practice cosine, because here's my 30-degree angle. I'm looking for this little section right here, and I'm going to highlight this in pink, because I'm only looking for this section because we're dealing with that right triangle. Okay? So I'm going to say the cosine of 30 degrees equals, let's call it x because we don't know what it is, and the whole entire thing is b, over 12.75. So x equals cosine, now let's write it 12.75 times cosine 30. And that gives me 12.75 times cosine 30, and you can put this in your calculator with me. X is approximately, and let's round to the nearest thousandth, let's say, 11.042, because we can do that, the nearest thousandth. Now I know that this is 11.042. I also know that this side is 11.042. So again, I'm just going to redraw this triangle, right? Just because I can. And I know that the height of this triangle is 6.375. There's a lot of work here, right? And the base of this triangle is 22.084. And all I did was add those two guys together. That's it. So now I can find the area of this triangle, because the area of a triangle is half base times height. And again, this is all stuff that you know. So I plug this in, half base times height, 6.375, or height times base, it doesn't matter, 22.084. And I actually just do the math in my calculator. So, and it doesn't matter which order I put it in, right? Because multiplication is commutative. So I do all that, and I get the area equals 70.393. Let's round this to the nearest thousandth. Okay? Hundredth. No, let's round this to the nearest, let's round this to the nearest thousandth. So in your calculator, you should have gotten 70.39275. And that 7 makes this round to a 3. So what is that going to tell me? Well, if I know that this area, and I'm going to bring it back to this picture, if I know that the area of this triangle is 7.393, I can get the area of this segment. So I just go back and I do my math. And let's do it on a calculator to make it easy. The area of the whole sector that we got before is 170.24. I subtract that triangle because it's not part of the shaded region anymore, 393, and I get 99.847 square feet. So that's a lot of work, and you can practice that on your own, but we're also going to do this in class. I'm going to give you one to look at. Here's one to look at. And I'm going to get a little closer there. And this will be the last one to look at. So again, I want you to look at, we're going to look at this one together, and then I want you to do this one for homework. Okay? So you're going to have to, like, you know, capture the screen on these so you can practice some of these. So let's try this one. I'm going to, with my pink, I'm going to draw the whole thing because we're going to get the sector. So we have to try to figure out the sector. with a 60-degree angle. Okay? So I know that the area of the entire circle is 25 pi because it's pi r squared. I know that the fraction of the circle is going to be 60 over 360, which is 1/6. So I have to get the entire sector, I have to take 1/6 of 25 pi. And so again, I put this in my calculator, 25 pi divided by 6, and I get approximately, let's run to the nearest thousandth again. Ooh, thousandth is hard, right? Yeah, let's run to the nearest hundredth for fun. 13.09, okay? And this doesn't have any units on here, so it's square units. We could write the units, but again, we don't have to because it doesn't have any units. All right? So that's the area of the sector. But what we want, and I'm going to highlight this in green, is only the segment. What is this tiny little bit there? That tiny little bit there is going to be what we have to find. So let's remember that the sector minus the triangle equals the segment. So we have to find the area of the triangle. And again, it's going to take a little bit of work. It's a equilateral triangle because it's a 60 degree. So this is 5 and this is 5. Isn't that nice? Ugh. We have the base of this triangle now. So now all we have to do is figure out the height. And we should be able to have that in our brain, but let's go ahead and do it the long way. So again, I'm just going to draw it a little bigger so you can see it. I know that the side is 5. I have to draw my altitude, which is perpendicular. Okay. I know that this side is 5. This side is 60 because it's an equilateral triangle. So how do I find the height? I can use sine height. Here's the height. So again, I can use sine. So we're going back to that trigonometry. So I got to adjust this a little bit. Okay. Let me adjust that. Okay. So how do we do this? Well, we do the sine of 60 degrees equals h over 5 because it's the height over the hypotenuse. Opposite over hypotenuse. So the height of this triangle is 5 times sine 60. I do that in my calculator. 5 times sine 60 is about, still there? Yeah. Is about 4.33. Let's just round to the nearest hundredth. So this height is 4.33. So that's the height. So how do I find the area of this triangle? Well, I'm going to just go over here and do the math. Area of a triangle is 1/2 base times height. And remember, this is all stuff that you know how to do. You just have to be reminded. 1/2 base is 5 times height is 4.33 approximately. So remember, this is just approximate, but it's still the right math. So in the calculator, we're going to do 0.5 times 5 times 4.33. So the area of this triangle equals 10.825, and I can use the whole thing because it ends. So the question is, what is the area of the segment? I'm going to go back to this statement right here. So if we know the area of the sector is 13.09 square units, and the area of the triangle is 10.825 square units, then the area of the segment is going to be the difference of those numbers. And doesn't that make sense? That's a really tiny, tiny piece. 13.09 minus 10.825, and that gives me the area of the segment to be approximately 2.265 square units. And that's our answer. That's our final answer. Okay. So again, I want you to take a screenshot of that, and I want you to try 18 on your own tonight. I'm going to show you a couple more things that you're going to have to pause and try on your own. Okay, so I'm going to go back to this one. Here's our sector page. I want to take you a screenshot of that, and I want you to try 9 and 12 and 13. And then I want you to take a screenshot of this last one right here. And I want you to try these two. Okay? So this one is a very similar one that we just did. And this is pretty close to something that I want you to try on your own. Okay? So screenshot that, and we'll talk about those when we get to class on Monday. Have a good weekend.